The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and good afternoon if you're located in different parts of the world. Thank you very much for joining today's distributor technical webinar that is focused on Omicron's distributors only. Today we are going to be going through a few product updates as well as some competitor updates. I hope everybody is keeping healthy and safe. And looking forward to seeing all of you soon, hopefully. So let's get started. My name is Effie Melissa. I'm the head of product. Most of you already know me quite well. And I believe a number of my colleagues, of the Omicron colleagues, are also on the webinar listening in right now. So if you have any questions for any of us, please let us know. Feel free to put in questions into the question box on the bottom right of your screen, or just unmute yourselves at the very end of the session to ask it, because we will have a live question and answer session anyway. So as always, let's begin with a little bit of an agenda. We will begin with a small introduction and general updates, and then we will go into the product updates, starting with OmniType and the EAP phases that are ongoing. And then we will continue with product updates on HLA Twin version 4.2. We will move on with a competitor update and comparison for your information. Mind you, a lot of the competitor information obviously is based on on what we currently know. There are certain delays due to the COVID pandemic, but this is to our best knowledge right now. And of course, we will be finishing off with a summary, closing remarks, and a live question and answer, so we can answer any questions you may have. So let's begin with an introduction and general updates at this point. First of all, we have some team updates. A lot of you probably already know, but I did want to re-emphasize the fact that we are restructuring a little bit the company. Everything is operating and everything is moving on without any disruption at all. So you shouldn't actually have any direct effect of the team updates that I will be giving you. But there will be some new people that you will be hearing the names already. You probably know quite a few of them already. So first off, our previous CEO, Peter Manges, has stepped down and he has moved on to another fun opportunity. And Attila Berches, who is the founder and chairman of Omicron, has stepped in as the new CEO of the company. A lot of you probably already know Attila because he has been with the company from the very, very beginning, and he has been very actively involved as well. So he's very familiar with the company, the vision, the operation of it. So we expect a very, very smooth transition. Additionally, we have a new Vice President of Commercial Operations, Gregory Werner. So Gregory comes from a much bigger company. He used to work at Linkage Biosciences and then at Thermo Fisher. And he has a very extensive experience in the HLA field. So he's bringing all of that experience from both companies and HLA to work with us. And we're very happy to have him on board. A lot of you probably have already talked with him, but if not, I am sure that you will be hearing from him in the upcoming weeks. So exactly because we have had a couple of team updates and changes, I figured we should probably count up again how many people we are. We're 55 people from 7 countries. 48 people in Hungary, 4 people in Europe outside of Hungary, and 3 people in the USA currently. We still have our contracted manufacturing in the USA, R&D in Budapest for both assay and software, and of course a lot of R&D partners around the world in Pennsylvania, Iowa, North Carolina, and Germany. We do have and maintain 3 warehouses, 1 in the US and 2 in different locations in Europe, in order to be able to better support our customers and your customers around the globe. So, of course, Omicron, this is just an updated map. As you can see, we are located, the orange circles is where the Omicron employees are located, but in all reality, Omicron is very heavily relying on you, our distributors. And just looking at the map, you can see that we are able to cover multiple geographic locations. We have a very, very heavy presence in the majority of the world thanks to you. So we very much appreciate your work, and that's exactly why we're holding these continuous distributor webinars in order to keep you updated on products and also to make sure that you have all of the relevant information to be as successful as you can be in your territory. So I'm always asked to put this information into all of the presentations as reminders. So I'm happy to do so. Some of our requirements from you. We always appreciate that you send us your yearly marketing and conference plan in order to be able to make the necessary arrangements for either Omixon staff to join you at various conferences, to provide any collateral you may need, and to help with any preparation and with resources that you may require for each occasion. So we appreciate that you send that to us in advance. We always require a monthly or quarterly sales forecast in order to make sure that we have enough stock, enough kits with all of the appropriate expiration dates manufactured and kitted up, and prevent any delays in supporting and providing the products to the customers. So this is actually very, very important for us to have in advance. Our manufacturing plan depends on this. All of the distributor contracts have been updated with holotype v3 configurations and OmniType configurations for the EAP. If you have not received the updated version yet, I am pretty sure Nora and Greg, my two colleagues that are heavily involved in this process and are in touch with you, will be getting in contact with you in the upcoming week. So you should see these ones coming in soon. Please share all of the tender notifications and specifications as soon as possible. The sooner we find out about this information, the more time we have in order to formulate the best possible responses and give all of us the best chance of winning every particular tender. Sometimes we need to create certain documentation from scratch, or we may need to request certain documentation from third parties, and that takes a little bit of time. So the sooner we know, the better it is. And just a final, one last friendly reminder that information about Omixon should be on the websites of all of our active distributors with either the Omixon logo or product information, whatever you prefer. If you do not have the required information, please reach out to us, myself, Greg, Nora, our support team, our sales team, and we will make sure that we provide all of this necessary information. Okay, so let's go into the more fun part, the product updates, which is why we're here today. So let's start with the OmniType. Everybody knows what OmniType is by now, I hope, but just as a little reminder, OmniType is Omixon's new multiplex genotyping product for the comprehensive gene amplification of multiple HLA loci, 11 to be exact, and sequencing on Illumina platforms. HLA Twin, which is the only software that has been specifically designed for HLA data analysis by NGS, is always included in the kit, just the same as any other Omixon product. And as a result, the combination of the two can provide fast and accurate genotyping, which is now available in a multiplex fashion. So this is a product that the market has been asking for a very long time, and we are very happy that we are finally able to deliver something very, very, very good and very accurate. The OmniType EAP phase 1, as you probably all know, it started much earlier this year. So it was launched in January of 2020. Just a little bit of a recap of the phase 1 technical information as a reminder. You were able to go from DNA to library in about 6 hours for the entire workflow. This included 2 hours of hands-on time. All 11 loci, HLA loci, could be amplified in one single tube. There are 2 magnetic bead-based steps in the workflow, one for amplicon purification and one for size selection. And it also included a very fast library preparation workflow with pre-mixed and pre-aliquoted library preparation reagents, which makes things much easier. We will go into a bit more detail on all of this further down. So what have we actually learned and what has been done during this time? So during the phase 1 testing of the early access program of the OmniType, 8 laboratories tested worldwide in the US, EMEA, South Africa. Each site did one run of 24 samples. The data of 6 of these runs have already been received by Omixon and analyzed, and these are comprised by a total of 144 samples. And unfortunately, 2 libraries have not been sequenced yet due to the current COVID-19 restrictions, but the data will be shared with us when it is available. So what we have learned, we have had, of course, lots of feedback because this was a very big purpose of the early access program. So we've had both good and bad. So let's start with the good. This is just a high-level summary. We have much more detailed feedback, in fact, but I only summarized a few key points here. So the good, people thought that it is a very simple workflow overall. It is very easily doable in an 8-hour shift, which is a very, very big selling point in most cases, in pretty much in every case. It has a very fast PCR amplification reaction and easy setup of that reaction. People really enjoyed the pre-aliquoted and color-coded reagents in the library preparation because it significantly reduces the risk during the technical preparation of the protocol. And also we received a lot of positive feedback for the low DNA input requirement of the protocol. On the other side, we also had some bad or some not as good, let's say, feedback. So most people felt that the amplicon purification step is too laborious because it is done in a 96 well magnetic plate, and it is high risk for cross-contamination and carryover during this step. People did not enjoy the single tube indices because you have to mix and match different tubes together. So that is too risky and complicated to do, very high risk for the user. So they did not enjoy that there was a low sample throughput per run. So there is a limitation, or there was rather, I should say, a limitation on the number of samples that the user could process in a single run. There were some specific allele-specific imbalances, and of course the data analysis was taking too long. So this is all of the feedback that, this is actually the high-level feedback that we received from the phase 1 testing. And during this time, we have actually managed, or during the last month and a half, I should say, where things slowed down quite a bit due to the pandemic that is going on. Our R&D lab, assay R&D lab, did not stop working. So they have managed to get all of this feedback addressed and incorporated into an updated version of the OmniType product. This updated version of the OmniType product is essentially what will be tested in phase 2 of the early access program. Phase 2 of the early access program is starting in mid-May, so in less than 2 weeks by now. And priority will be given to laboratories that have already tested in phase 1 and they are familiar with the protocol, or to NGS experts. And the reason why is because these laboratories will probably have to do the protocol, the workflow on their own without on-site fast support, because there are still a lot of travel restrictions and bans in various countries. So we are not exactly sure when we will be able to resume that activity yet. However, the testing can start for these cases, and we will be supporting everybody remotely over the phone, on web meetings, and so on. So you can always count that the customers will always have an Omixon staff supporting them remotely even during this process. So the phase 2 OmniType product, as I said, all of the feedback was addressed and a few protocol changes have been made that have resulted in a 1.5 hours hands-on time, which is a reduction by 30 minutes from the original workflow. It also has resulted in a reduction in the turnaround time, and now the entire workflow is about 5.5 hours, which makes it the fastest multiplex workflow in the market right now, which is great news, makes it a very, very competitive product. We also have changed the primer ratios in the multiplex primer mix tube to make them to make them more balanced. So there is an optimized balanced primer ratios, concentration ratios. This has resulted in a higher sample throughput per run, which is a very, very big advantage and one of the bad pieces of feedback that we received. And with this higher sample throughput, we currently estimate, and this is very, very important, that all of the numbers that I'm giving you right now, they are estimations only, and further testing is ongoing right now. But we estimate that 24 samples can be run on a microflow cell, and at least 72 samples can be run on a standard flow cell. As I mentioned, these are under testing right now. These are only estimates, and they are of course subject to change, but there's a significant improvement to the numbers that we were facing with previously, that were significantly reduced to what you see here. The allele-specific imbalances have been resolved, and one of my personal favorite improvements, the amplicon purification step, has been removed. And this is a step that a lot of people felt that it was too risky and they did not like doing it. So I'm very, very happy that our R&D team has actually managed to make certain modifications to be able to remove this step. And of course, last but not least by any means, there have been several data analysis related fixes that have improved the quality of the genotypes and the quality of the data in the end, as well as the speed. And I will talk about that in the HLA twin section. So I do have a little bit of a technical overview of the workflow as a reminder again, and also to highlight what the differences are in comparison to the previous workflow. So the two pre-PCR steps, step 1 and step 2, we start with the genomic DNA dilution and PCR master mix preparation, which takes 20 minutes or less. Everything is based on 24 samples, by the way. The long-range PCR amplification, which takes about 2 hours and 15 minutes. And then moving on to the post-PCR steps, we begin with the amplicon quantitation and dilution, which takes about 30 minutes. Fragmentation and reperinate tailing, all done in a single reaction, takes about 8 minutes. Step 5, we have the adaptor ligation, which takes 20 minutes. Step 6 is the indexing PCR, which takes about 20 minutes as well. Step 7, library pooling and size selection. This still takes about an hour. And step 8, we have the library quantitation with a qubit, about 10 minutes. And finally, the last step would be the MySeq loading, which takes about 20 minutes at this point. If you add up all of these times, the total time comes down to about 5 hours and 15 minutes. I usually say 5 hours and a half because you always lose a little bit of time right here and there. But you can still see that it is a very short workflow. It can very easily be done in one single day with multiple breaks, lunch breaks, can accommodate various timelines and schedules in a laboratory. So I do have a more technical overview. I saw that a few of our people that actually joined today are on the technical side, so I wanted to make sure that I do provide this information for them. So as I mentioned before, step 1, we start with the genomic DNA dilution and multiplex master mix preparation. Nothing has changed in the actual PCR setup itself. We dilute the samples to 100 nanograms per sample. This is the DNA requirement right here. And then we just mix the PCR master mix with the 24 samples in a 96 well plate. Important to note that you only need one 96 well plate, and as a result, one PCR machine for amplification of up to 96 samples, which saves a lot in consumables and of course equipment. So once we have the amplification plate prepared, it goes into the PCR machine. Remember that up to 96 samples, you only need one PCR machine, and that reaction takes about 2 hours and 15 minutes. The expected amplicon sizes have not changed in comparison to the previous version of the OmniType product. And the reason why is that the primers themselves have not changed, but the concentration ratios between the various primers in the tube has changed. So as a result, the amplicon sizes remain the same. Once the amplification is complete, we move on to the amplicon quantitation and dilution. You have two options for the amplicon quantitation. You can either use a qubit and qubit reagents, or a plate fluorometer or qPCR instrument and quantiflow reagents, depending on how many samples you're quantitating and what you have available. As always, we do provide a workbook to do all of the calculations and all of the necessary and give you all of the necessary indications for every step in the workflow. And in this particular step, we do have the workbook guided standardized amplicon dilutions that is telling you how much water you need to add into every well, which is very convenient. The workbook, as always, it is a very, very big plus by laboratories, and they all appreciate the fact that we provide this and that we facilitate their workflow in this manner. Then we go into the OmniType library preparation with step 4, which is the fragment Taylor reagent, which essentially it's a fragmentation and repair and a tailing reaction that takes place into one step. During this step, we fragment the amplicons into smaller pieces, and we repair and adenylate the ends of those fragmented amplicons. So essentially all we have to do is take our purified amplicons and mix them into a new plate with the fragment Taylor mix, reagent mix, which comes pre-mixed and pre-aliquoted in a color-coded strip tube, purple in this particular case, which makes it very easy to make sure that you pick out the correct reagent out of your box, and then you put that in the PCR machine for the reaction. So pretty straightforward. The setup enables use of multi-channel pipettes to save time, save pipetting steps, reduce the risk of making mistakes during the setup, and so on. Once the fragment Taylor reaction is complete, the next step is the adapter ligation of the I5 and I7 adapters. So once again, we take the same plate that we were using previously, and we add the adapter mix that comes pre-mixed and pre-aliquoted in a black color-coded strip tube, and the ligation mix that comes pre-mixed and pre-aliquoted in a blue strip tube. So both of these reagents are mixed in the existing library preparation plate and then put in a PCR machine. The advantage that you see here essentially is that we are using the same plate throughout the entire library preparation process, and that makes it and that reduces the amount of consumables that are required for the workflow. So step 6 is the indexing PCR with the unique indices for each sample. So currently for the early access program, we still use the individual index tubes that customers essentially have to mix and match which tube to use with for what sample. However, this is going to be changing in the future, and this will be provided in the RUO released version. They will be provided as pre-plated indices, so to reduce the reduce the risk of making mistakes and combining different tubes that you shouldn't. So once again, for the indexing PCR mix, we have the green strip tube that contains the pre-mixed and pre-aliquoted PCR mix that is added into the library preparation plate, as well as the appropriate indices. That goes again in the PCR machine for the reaction to take place. And once we have our indexed samples, we can go ahead and pull all of the libraries together. So we pull into a single tube, and then we perform the size selection step that is essentially comprised of 2 selection steps for the optimal fragment size selection. Once we have our size selected library, we can quantitate it using the qubit. Nothing new here. Follow the manufacturer's recommendations and instructions. And finally, we load the library on the MySeq. It is important to know that during the early access program, of course, we only support running these libraries on the MySeq. But in the future, we will be testing and making sure that they work on other instruments as well. In theory, there should be no difference whether you're running the OmniType libraries on a MySeq or a MiniSeq or any other Illumina instrument, but we always want to make sure that we have things tested before we recommend that people can use them. So, to sum up essentially on what exists right now and what we estimate for current availabilities. So right now we have the 11 locus EAP kit configuration, the phase 2, as I mentioned earlier. That is going to be the phase 1 was available in the Q1 of 2020. The phase 2 kit is going to be available in a couple of weeks. We currently support this in 24 sample kits. We only provide that for the early access program testing. The 11 locus RUO kit, however, is going to be available in 24 sample and 96 sample configurations. We estimate this to be available in Q3 of 2020. The original timeline was end of June. However, we do foresee that there might be a bit of a delay due to the COVID pandemic and because the external testing has been delayed since a lot of laboratories are working on limited capacity right now. But we do not anticipate that it will be delayed significantly. And then it is under discussion on providing a 5 and 7 locus multiplex configuration as well. The Q4 2020 that I have marked here, it's tentative availability with very bold tentative, with emphasis on the tentative. Essentially, the decision on whether we should be providing this or not, it is dependent on the market requirement. So it is very important to get feedback from you and your individual territories, what their needs are and what would work and make you successful there. So for the RUO products, we do anticipate that we will have pre-plated indices, support on various Illumina instruments, HiSeq, MiniSeq, MySeq, and so on. Of course, all of the flow cells will be supported depending on the instrument. The 300 cycle chemistry is very highly recommended, but if somebody wants to use a 500 cycle chemistry as well, it can be supported. It doesn't make much of a difference. And finally, the CE marking of the RUO, the 11 locus RUO product, it will be very heavy. It will be dependent on the successful completion of the EAP. So I cannot provide a timeline for that right now or a particular date for that right now when we will have it, but it is estimated to be in Q1 2021. One of the reasons why that cannot really be done much sooner than that is because most of the notifying, or all rather of the notifying bodies, are consumed with approvals, with reviewing and approvals of COVID testing kits right now. And as a result, those are their number one priority, and all of the other products are lower on the priority list. So we have been given a much longer wait time for this from the notifying bodies. Having said that, we will be initiating obviously all of the necessary testing that is required once the RUO product is released, in order to be ready as soon as we can, and then just submit everything to the notifying body and wait for them. So the EAP, of course, is still ongoing. So if you do have any customers that would like to participate, we can still enroll them in that. We do have certain requirements, of course, and participant benefits. So the participants, how do they benefit? They get up to 48 samples free of charge for testing. And they can potentially get up to 96 samples at special discount for validation should they decide to sign a contract with Omixon for long-term use. Of course, they get free on-site training with an Omics on FAS and the ability to influence the assay and software product development as always. But of course, they also have some obligations. So they are required to provide all of the data, workbooks, and feedback back to Omixon. Test samples with known typings, preferably with 11 locus known typings. I do understand that in certain regions, especially in Europe, laboratories do not have this information, but if they do, we do require those. And of course, provide all of the feedback, as I mentioned, back to Omixon as requested. There are also some technical requirements at this point. We do want people to be using Verity PCR machines and also to be using MySeq 300 cycle reagent kits and standard flow cells. The reason why we have these technical requirements is in order to remove as many variables as we can from the testing, and in order to have comparable data and amounts of data to do meta-analysis internally. This is a very, very important point for us. So let us know if any of your customers are interested. We will be more than happy to reach out and start the discussions and signing them up. Okay, so that's all about OmniType for now. Let's move on to some more product updates on HLA Twin version 4.2. So there has been, the version 4.2 was released a short while after the previous version was released. So all of you would remember that the version 4.1 was released in late December of 2019, and version 4.2 was released in March, end of March of 2020. I'm sorry, I blanked on the date for a moment. There are two editions available for version 4.2, RUO and CE. And the reason why I actually started with an introduction to compare when the previous version was released versus this one is because we have had a project that has been ongoing for a very long time, and it has been focusing on analysis speed improvements. And we have come to a point where these analysis speed improvements were so significant that we didn't want to wait for a very long time before we made those available to our customers. One of the main reasons why is because analysis speed has been one of the main complaints that people have and pieces of feedback that people have brought back to us. So we wanted to make sure that people are enjoying these improvements as soon as possible. So all of these improvements have been incorporated into this new HLA Twin version release. And what do this actually mean is that we introduced a fast mode. I will talk about this in a subsequent slide a little bit more, which has enabled the analysis time to be reduced by 70 to 75%, which is a very, very significant number. The analysis time has also become completely, or almost completely, I should say, independent of the IMGT HLA database size, which keeps getting bigger and bigger with every IMGT release. And that is actually one of the biggest hurdles for the analysis itself. It also, the result file size has been significantly reduced, which what it means is that exactly because the file size is much smaller, it takes less time for it to be saved. And that has a direct impact on the analysis speed as well as a whole. And of course, all of this comes with no degradation in HLA genotyping, which is obviously one of the most important factors. We still want to have the accuracy, sensitivity, and sensitivity that we require and our customers require from us. So what exactly is fast mode and what does it look like? So the fast mode analysis pipeline has been introduced in HLA Twin version 4.2. It is run by default. But as you can see in this screenshot that I have entered right here, we do have an option that is called pipeline execution mode, and the legacy mode, which is the previous method that we were using, is also still available. a lot of people actually have asked, well, why is this still available? What is the point? Why would anybody want to use this? Well, the only reason why is because we do understand that some laboratories may want to validate the fast mode against the legacy mode. And as a result, we want to be able to give them this option. So the legacy mode is still available for people to do all of their comparison studies that they may require, or they may not, and they may want to just go on and use the fast mode as it is. And we do envision that this will still be there for the next couple of HLA twin versions until people are just not using it anymore and do not require to do any more studies, comparison studies, that is. So what are the differences between the legacy mode and the fast mode? There are essentially two major differences here. First of all, and probably the most significant one, is the gene filtering step that has been reworked entirely. So the gene filtering step does not use the entire IMGT HLA database for locus-specific filtering anymore. So this is the very, very first step in the entire analysis pipeline for every sample. The way that the analysis starts is that the algorithm goes through all of the short reads that come out of the sequencer, and it tries to figure out which locus each read belongs to. When it tries to do a rough comparison of every read to the entire IMGT database, that takes a very, very long time. So what we have done is that we have taken a representative allele set from the entire IMGT database, which is essentially just a subset of the whole database, that can be used for this particular step and still produce the same results. So it is important to note, however, that this representative allele set is only used for the very first gene filtering step. The genotyping itself is done using the entire IMGT HLA database. And this is exactly why no degradation is introduced in the genotyping result. Because there has been this rework for this step, and the IMGT database is very heavily involved in this, the fast mode only works with the IMGT HLA, or rather I should say that the maximum improvement in analysis speed can be achieved when it is used with the IMGT HLA version 3.38 or newer. You will still get an improvement in the analysis speed if you use an older IMGT database with the fast mode, but not the maximum effect. So it is not actually recommended for that reason. The second difference between the fast mode and the legacy mode are certain changes in the result HTR files, which is exactly what I mentioned earlier. So the file size has become significantly smaller, and the reason why is because a lot of information that used to be stored in them is not stored in them anymore. This information that is not stored in them anymore is calculated very quickly every time that you open the gene browser of the software. As a result, the HTR file sizes have decreased from a few hundred megabases down to 10 to 20 megabases per sample. So this has two direct impacts, essentially. The first direct impact is that because the file size has become much smaller, it takes much less time to be saved, and that has a direct impact on the overall analysis time for every sample. The second impact that this has is that essentially for long-term storage, you do not require a very large storage capacity anymore, but you can actually use smaller storage capacities in order to store all of your samples for long-term purposes, exactly because every file size is so much smaller. So these are the two most significant differences between the fast mode and the legacy mode of the analysis of the software. So of course, all of this is great, but what does this mean? Obviously, most people want to be able to see times. So the analysis times per sample with satisfactory IT specifications, and this is very important because IT specifications can differ from place to place, are estimated to be what you see in this table. So for a holotype HLA 5 locus sample with a fast mode, it takes approximately 3 to 4 minutes to be analyzed, whereas with a legacy mode, it used to take 10 minutes or more to be analyzed. With a holotype HLA 7 locus sample, it is very comparable. The analysis time is very comparable to the 5 locus ones. So about 3 to 4 minutes with the fast mode versus more than 10 minutes, 10 to 12 minutes with the legacy mode. With the holotype HLA 11 locus samples, more loci, takes more time, of course. It takes approximately 4 to 5 minutes in the fast mode, whereas it used to take 18, 20 minutes plus with the legacy mode. The OmniType 11 locus samples, it takes approximately 10 minutes in the fast mode right now, when it used to take 30, 40, 15 minutes, 50 minutes plus in the legacy mode. It actually used to be very, very long. And it is, as we saw earlier, the analysis speed for the OmniType samples was one of the bad pieces of feedback that we received. So as you can see now, this has been reduced to approximately 10 minutes per OmniType 11 locus sample, which is a very, very big improvement to what it was before. Now, it is important to remember that certain improvements are still ongoing in the phase 2 of the OmniType EAP, and the ultimate goal is to reach a time that is comparable to the holotype HLA analysis time, which is 5 minutes or less. So all of this work is still ongoing. Now, I talked a little bit about the IT specifications and why these are important. And we have definitely seen that in different locations and different laboratories, the IT setup is very different, and that has a direct impact on the analysis times that laboratories and users experience. Our technical specifications have not changed. However, we definitely have done studies that show that they could potentially be reduced. However, we haven't actually touched anything quite yet. They are still, the software is still available on all of the different setups that they were before. So it is still supported on a desktop setup and the client server setup. And I would like to focus a little bit more on the client server setup. So on the server side, we have two different servers in a way that are bundled into one, but perform different parts of the analysis. We have the typer server that, as the name indicates, it essentially is the instance of the server that does all of the analysis, all of the genotyping, and all of the work, essentially. And that is the reason why it requires a larger amount of RAM allocated to this. And then we have the reporting server, which is essentially the instance of the software that does all of the reporting. So it is the one that shows the result. It calculates a lot of the metrics that we see, and it is the instance where the user essentially works mostly with. And this is why not a lot of RAM is needed for this particular instance. Now, we talked a little bit about all of the per sample improvements in terms of the analysis speed that we have done recently, but I also wanted to make sure that everybody is aware on additional methods that one has in order to reduce the analysis time per batch, per run, per group of samples, not per sample individually. So what we do have, and what we do recommend people to do when they want to reduce the analysis time per batch as well, is using parallelized typer servers. So essentially what that means is that if you have a big server with a lot of RAM, you can split that amount. You can install multiple typer server instances and split the amount of RAM between those typer servers. There is no particular limitation on the number of typer servers that you have. And what essentially this means is that if you have one typer server, and you have a batch of 24 samples, all 24 samples will be run through, will be analyzed by that one typer server. If you're using two typer servers in parallel, that means that the 24 sample batch will be split into 12 samples will be analyzed by one typer server instance, and the other 12 samples will be analyzed by the other typer server, by the second typer server instance in parallel. And as a result, the analysis time for the entire batch will be divided by 2. If you had 3 typer server instances, then the batch would be split by 3. Each typer server instance would analyze a subset of the entire batch, and as a result, the analysis time for the entire batch would be divided by 3, and so on. Both physical and virtual servers are supported for this particular setup. And if any of you or your customers are interested in setting this up, we are fully aware that a lot of our customers are actually already using this with great success and very much like this. But if you have any new people that are interested in setting this up, feel free to reach out to any of us, the sales team or the support team. The support team is obviously much more appropriate for this particular work, and they will help them, and our support team will be directly involved to help them set this up in their own environment. So we talked a lot about analysis speed because this has been one very big pain point for a lot of people, but obviously we have done some more improvements and some more work to the software, and I don't want to put those in the back burner because they are actually quite significant as well. There have been a lot of bug fixing and behavioral fixes. So a GUI bug where the reference database was not handled properly is now handled properly and displaying all of the necessary information. So that has been fixed. There has been a behavioral improvement where the software will not crash if the HLA twin severed application has an incorrect IP address. It will still continue analyzing the samples as normal. Some export bugs have been fixed. So an issue with exporting PNG group precision in HTML and PDF has been resolved, and an assigned hemizygous alleles are now exported properly. There have been also a number of H-Prim specific export bugs. So H-Prim is essentially a service, is a format that French laboratories are using, and they were having a lot of problems with them. So a lot of related export bugs to those have also been fixed. Namely, homozygous novelties are now reported correctly according to their specification. Novelties are named properly on the fourth field. Hemizygous alleles are exported properly. Only the last comment is exported instead of the entire history per EFS's request. And of course, all of the comments are now comply with EFS's, the French laboratories specifications. It's a very long list, but it is very, very specific, and it does require quite a bit of work. This is why it's very important. So what does this mean? So we have done a lot of work on HLA twin the past year, several months, I should say. You're all very, very familiar with the refactor project that we had going on that improved the overall performance of the software and the responsiveness of the software while the user was reviewing data. We just talked about the analysis speed improvements that took place. So what is still on our roadmap? There are a lot of features and a lot of work that is going on. So I would like to share some of those with you. So, of course, our ongoing priority project is to further reduce the analysis time per sample in the software. And this includes the ultimate goal of bringing the OmniType 11 locus sample analysis time to less than 5 minutes to match exactly what the holotype samples are doing right now. So this is still ongoing, and it is still considered high priority. But we also, as I mentioned, we also have some new features that are planned. So we will be introducing a custom database support, which essentially what this means is that laboratories will be able to upload their local databases if they have a local database in a particular format that we will tell them what that is into the software, and they will be able to use that in the software. This is particularly useful and important for remote countries where the local populations are not as well characterized or as well represented in the IMGT database or other very commonly used databases. So this is going to be particularly important for those populations like in Asia, the Middle East, in certain African countries, and so on. We will also be introducing an extension for Class 1 LD for the relevant associations. We currently use that for DQB and DRB associations, but we will be extending that for Class 1 as well. We will be introducing a statistical module that will allow the users to essentially query and find statistics on local information, such as, let's say, the frequency of particular alleles or null alleles or novel alleles in their local data, which is very nice and informative. And we are also working on an advanced integration with PERCH for epitope analysis. You are all very familiar with the fact that HLA Twin already interfaces with PERCH to do epitope analysis, but we will be doing a more involved integration of the two programs in the future. Okay, so this is all of the product updates that I had for you. I know that I'm actually running a little bit short in time, but I would like to go through the competitor updates very briefly, although there are really not that many from the last time that we talked. So the competitive landscape, nothing has changed here. Our NGS competitors are KDX, GenDx1, Lambda, Immucor, and of course us, Omixon. And let's start with the CareDx update. So CareDx has the AlloSeq TX product, which is a multiplex product for HLA typing by NGS. It uses a hybrid capture approach, which is the first one in the market and the biggest difference in comparison to all of the other multiplex products in the market right now. There are two configurations that will be available. One is the TX17 and the other is the TX6. The TX17 essentially includes all of the classical HLA loci, some non-classical HLA loci, MIC-A, MIC-B, and some more SNPs. One point of difference in this particular protocol is that it does allow for very early index sample pooling in the library preparation step. So that simplifies the workflow in many ways. It currently takes about 8 hours for the entire workflow to be performed. It's actually just a little bit over 8 hours based on my understanding. So it can potentially be done in one working day, but squeezed into it. They do have an improved software with a very fast algorithm right now that is completely redesigned. The algorithm analysis part is completely redesigned. The testing is currently ongoing, and they have not actually announced an official launch date quite yet. However, because of the COVID situation, they may choose to just release a product and get people to use it quietly. So it is important to keep an eye on what our other customers that are using or testing this product right now are doing. Moving on to GenDx. So GenDx has a PCR-based multiplex product in the market that is called NGSX6 already. This is publicly released as an RUO and CE mark product. The CE was announced at the very end of January, I believe. This is for the analysis of HLA A, B, C, DRB1, DQB1, and DPB1. But they are also having an 11 locus multiplex under testing right now. Based on a very recent webinar that they gave on this 11 locus multiplex, it is still going to be you will still need 3 tubes to be able to cover all 11 loci. So this is not a single tube multiplex product, and there is no information that they are working on a single tube multiplex product right now. So this is one very big point of difference in comparison to other multiplex products for 11 loci. This requires 3 tubes, others require only 1 tube. They have announced that they will have expanded genomic coverage, which essentially means the inclusion of exon 1 of DRB1 and DPB1. The PCR time takes approximately 3 hours of the workflow. They use a classic library preparation protocol, so there is nothing very different or new there. And the turnaround time for the entire workflow from DNA to sequencing is approximately, it's a little bit less than 8 hours. So once again, this can be done in a single working day. Just one thing that just occurred to me right now is that when I am talking about turnaround time, I am referring to DNA to sequencing, to library ready for sequencing. So the sequencing time is not included in any of these turnaround times, but it's pretty standard because it's very comparable to all of them. And it is hands-off. Moving on to One Lambda. So OmniType was the very first multiplex product in the market, which means that the company has a lot of experience with it. They have received a lot of feedback from the market, and they are able to incorporate that into any subsequent products. We all know that there has been quite a bit of success in various geographic locations with this product as well. It is the 11 locus configuration of the OmniType is currently CE marked. But they are also working on an evolution of the OmniType, let's say, that is currently under development. It is called the OmniType Fastplex. It is also a PCR-based multiplex, and to my understanding, is actually the same PCR multiplex that OmniType uses right now. The PCR time is approximately 2.5 hours, which is very comparable to the OmniType. As far as we know, there is no additional genomic coverage, so no exon 1 for DRB1 or DPB1. Again, all of this may be subject to change. This is the current information that is available. However, they will be using a new library preparation approach that will allow for very early sample pooling in the first step of the library preparation method, which means that essentially the entire post-PCR workflow will be quite simplified, which is quite nice. The turnaround time will be approximately 5 hours, which would make this the shortest workflow in the market, but very, very close with the OmniType. So that the two products are expected to be very comparable in that sense. The current release for this particular product, I believe that it is expected to be sometime in Q2, Q3, based on the current information. Once again, because of the pandemic, we don't know what kind of delays or no delays that they may have. This is just the current information. Finally, we have Immucor. So Immucor have announced that they do have a multiplex product that is under development right now. It is the last company to bring a multiplex product to market. It will be available in 2 configurations, 6 and 11 loci. It is a PCR-based multiplex, and the PCR time, interestingly enough, will be about 5 hours, which is the longest one out of all of the products that are in the market. When they presented this about a year ago, they mentioned that they would have the same library preparation and reagents as their singleplex product, which means that this would bring the total time from DNA to a library ready for sequencing to about 12.5 hours, which means that this workflow would have to be done over 2 days and not in one single working day, which is going to be a very big point of difference overall. It is currently expected in Q4 of 2020. Once again, this is based on previous information, and we don't know how this have changed. The one piece of information that I found out very recently is that one of the reasons why this particular product is going to be released later in the year and has not yet is not because of the assay, but it is because of the software. There are rumors that Immucor is very heavily working on their software to redesign it and redevelop it to make the analysis time much faster, because it currently takes it currently takes more time than what is accepted by the market. So I have put all of this information in a side-by-side comparison and a summary just to make things a little bit easier to see. As you can see, the availability is relatively comparable in most cases, except for the Immucor being the last company to bring a multiplex product to market. The technology that is used to capture the HLA loci is PCR based for all of the products except for CareDx. That is the only point of difference that they have with the hybrid capture approach. The workflow complexity excuse me, is defined essentially by the number of pipetting steps and the number of pipetting steps that are required for every protocol. I expect most of these protocols to be very, very comparable, to be perfectly honest with you, with the CareDx and the Immucor one to be just a little bit higher in comparison to the others because of the particular steps that are required in the workflow and the length of the workflow. The DNA to sequencing is actually the turnaround time of DNA to sequencing is probably one of the more important metrics that will be discussed quite a bit in the future. So we can see that the OmniType and the OldType FastPlex are the shortest protocols in the market and are probably going to be the more comparable ones. CareDx and GenDx are a little bit longer, still being able to be done in one single working day, and Immucor will have to be split into 2 days. The input DNA, once again, is fairly comparable to all of them, between 50 and 150 nanograms, with the only exception of the OldType FastPlex that is expected to be as low as 10 nanograms. Now, one would say, does it really matter at this point whether it is 10 nanograms, 50 nanograms, or 100 nanograms, or 150 nanograms per DNA? Personally, I do not believe so, but because even for the more compromised samples where you don't have a lot of DNA, you sure have more than this low required amount. So I don't think this is going to be as important anymore, or as important as it was with the single plex products that were in the market. The analysis time for each sample, as we can see down here in the bottom of the table, currently the OmniType takes approximately 10 minutes, 10 to 12 minutes per sample. I already mentioned that there is ongoing work to reduce that to 5 minutes or less. This is the ultimate goal. The CareDx, GenDx, and OldType, they are all 5 minutes or less. And for the Immucor product, this is just an estimate because we don't actually have any information about this. So this is an estimate based on their singleplex product currently. It is expected to be lower than that based on the information that we have about their rework of their current software, however. So what you can see here is that essentially from a workflow perspective, there are a couple of points of difference, such as the technology that is used among different vendors and the turnaround time that is used among different vendors, but everything else is relatively comparable at this point. Of course, more information will be shared just as it becomes available, but for the time being, this is what we know. So with that, I would like to close up, provide a summary close up, and open the floor to questions and answers. So for us, it is extremely important to get feedback from you guys. What have you heard from the market? What is the competition like in your territories? What are your customers in your territory say, require? Any new requests they have? We need to know about this. We very heavily rely on you for for finding out information in your local market. So the more that you can share with us, the better it is, and the more we can serve your customers and our customers alike. Especially when it comes to particular feature requests for the products, different configurations of the products, new products potentially. It is extremely important to communicate all of that to us directly. You can either send an email to sales@omixon.com, support@omixon.com, your contacts within Omixon directly. It doesn't really matter as long as the information gets communicated back to us. This is extremely important. With the current COVID situation, of course, a lot of laboratories are finding ways to occupy their technicians as much as they can. So we have initiated multiple webinars, recordings, demos, HLA twin trainings remotely as much as we can. So feel free to visit our Omixon Academy and direct your customers to the Omixon Academy in order to register and get access to all of this information. If you have any trouble, of course, just let us know. We will direct you to the right place. And of course, the Omixon Academy and the Omixon website is always a good place for various resources and information of our products. So feel free to visit it anytime. So I would really love to open up the floor for questions. I will check if there are any down here in the questions box, but I don't really see any. If you raise the little hand, I will be able to unmute you and see if you and let you ask your question. Okay, I don't really see anything coming in or anybody raising their hand. So I guess we will be closing this down. But by all means, if anything comes up at any point, feel free to reach out to us, contact us, email us, call us. We are always available for you, and we are always available to answer questions and help you in any way that we can. So thank you very, very much for joining me and my team today. We will make sure to send this presentation and recording out to you for your information. Feel free to share the information that you like with your customers, and feel free to let us know if you have any questions or anything else that you would like to see in the future. Have a great day, everybody, and thank you for joining us.